Hello everyone, today I have this circuit right here. This is a spark gap transmitter. It's the very first radio ever invented, and this is the circuit for it. I have this car ignition coil that I scavenged for weeks to get, and I have this capacitor and this relay. The relay turns it off and on really fast, and the capacitor resonates with it. Now this is a very weird little high voltage circuit because I have the low voltage input, 12 volts, and then I have this relay coil. So this relay coil oscillates, and then this capacitor forms an LC tank. And why I said the ignition coil is such a weird transformer, because it doesn't work by the great winding turn ratio on the secondary. It works because it has so much energy stored in the primary with the capacitor and the huge inductance that generates a huge voltage spike, generating a huge voltage spike on the secondary. First of all, let's see it in action. I have this switch right here. This is the relay, and this is the capacitor. According to this schematic, yes, our high voltage out is technically VCC. So let's mark it. That's pretty powerful, I'd say. The only bad thing about it that it's mechanical. So if you don't want to make it with a relay and everything, you could just add a MOSFET right here and a 555 timer, and then just tune the frequency. Closer, a bit closer. You can see it jumps. So it jumps. It wants to jump to this. So yeah, so this is the highest voltage I can get, and it also arcs a bit to here. So let's remove that. Yeah, that's a pretty high voltage. Now I hooked that onto my spark gap right here and move this. Now it arcs across my spark gap. And now going on to the rest of the build, except for the ignition coil and everything. So I got the high voltage out connected to this capacitor, and the other side connecting to this right here. And this capacitor connects to this coil right here. The other part connects to the other part of the spark gap. And when the voltage, the high voltage, goes across the spark gap, it gets radio frequency. It emits a radio frequency of about 4 megahertz. There's no 4 megahertz stations where I live. And I have this antenna is useless. So I have this giga antenna onto my ceiling. And back to this is technically ground. And on the receiver I have this huge antenna going down to this. So this is the same inductance of the coil, 10 millihenry, same capacitors, and this circuit that gets all the input and turns this LED on. Now I'm zooming in onto the LED. The voltage was a bit too low, so the LED turns on. So I got this ignition coil right here, and I'm gonna take out the radio because this creates such a high voltage and radio frequency that it turns my LEDs on and my monitor off. So let's see the spark going here. Okay, and now I'm gonna try and get a shock from that. So I'm wearing rubber boots. Don't do that. Why did I do that? The reason why I safely did that is because I'm wearing rubber boots, and the rubber boots isolate me from ground, so I can't die. It just shocks me really bad because there's no current or voltage going across my heart or my vital organs. It just shocks me really bad. So after that shocking experiment, I got this receiver right here, and this is the LED. This should turn on. Turning off the lights. Now, this is not a project to be done at home. I'm a professional. This is not a fun project at all. You need huge antennas. I don't even have the right antenna size. I need a bigger antenna, and I know that. At 4 megahertz, I need like a 16-meter long antenna. Yeah, you can play with the ignition coil. It's pulsed. It won't kill you. It will hurt, but don't try and build a radio at home. So yeah, this is about it for today. See you next time. Another thing about this circuit, so if you're wondering how it works, is we have the high voltage side right here. So this doesn't matter, it just needs to be high voltage AC. And the primary resonates at a specific frequency that makes a huge voltage on the secondary right here. Then to add secondary, we make it resonate at the frequency of this capacitor and this inductor. Now we send that frequency up through the antenna, up, and we emit waves that go to this antenna right here. So this antenna, they go up to this. And here we have the same coil and capacitor combo. And since it's resonating at the same frequency, it's like, hey, I know that signal, I'ma pick it up. And it picks up that signal far better since it's resonating. And then the signal is picked up by my receiver with the transistors and it turns on. One last thing, I'm gonna try and write like and subscribe.